So that we'll work through it. All right, good morning, everybody. My name is Jason Marcasino. I'm from Team Rush. I'm our electrical and programming mentor and was one of our technical leaders going through the beta test process. So welcome, everybody. Thank you for waking up early on a Saturday morning to learn more about the 2015 FRC Control System. So I'm going to shift to the PowerPoint. All right. So the agenda for today. So we're going to go over the overview of the new controls hardware compared to the old hardware that we've had in previous years. Talk a little bit about controller area networks, or CAN, which is a new part or a large part this year of the new control system. We'll talk about the new web server interface called WebEx, some of the LabVIEW software changes that have happened, some of the lessons that we've learned during our beta test, some tips and tricks for the new control system, and then we'll open the floor up for questions. So things that are staying the same this year. So the battery is going to stay the same 12-volt battery that we've had for multiple years now. The approved router as of right now is still the D-Link DAP 1522 Route B that we've had for the past couple years. We still have the same snap action breakers. Still have a 120-volt circuit breaker off the battery. Still are approved to use the access camera. Speed controllers, the older style, well, the speed controllers that we had last year, Talons, Victors, and Jaguars, are all still legal. And you're still allowed to use the spike relays. Now you'll notice that some of the things up there have asterisks. We'll talk about those a little bit later in the presentation.
15 divided by 11, or 3 divided by 11.
So things that are changing. So your power distribution panel. So the old power distribution panel gave you 8 40-amp slots and 12, 30, or 20-amp slots. You had 24 volts for your C-RIO, 12 volts for your camera, and then 5 volts for the router. On the new power distribution board, you've got still your 8 40-amp slots for your larger motors. You have 8 30-amp, 20-amp slots for your smaller motors and other devices. 12 volts for the Robo-Rio. And then connections on the power distribution board that are dedicated for the voltage regulator module and the pneumatics control module, which are 2 new hardware components this year. You also have a connection for CAN. So you can use CAN for communication and diagnostics to the other devices. So some of the things that you can get back are current feedback from the power distribution board, temperature, battery voltage, all comes to the Robo-Rio transferred over CAN. And the PDP is now in a smaller package. So we've lost 4 of the 30-amp, 20-amp slots, so it's gotten a little bit shorter. And then added the additional CAN features.
The volume?
So the voltage regulator module. So the old voltage regulator module basically provided your 5 volts for the router, wired directly into the PDP. The new voltage regulator module has 2 12-volt 2-amp ports, 2 12-volt 500 milliamp ports, 2 5-volt 2-amp ports, and 2 5-volt 500 milliamp ports. So the voltage regulator can provide power for your custom circuits, cameras, the router, and it's powered with 12 volts from the power distribution panel. So they took away 4 of the 20-amp, 30-amp breaker slots on the power distribution panel, but gave you additional ports on the voltage regulator module. The pneumatic control module, or the PCM. So the old method provided voltage for 8 solenoids, either 12 volt or 24 volt, depending on your jumper setting. Interface directly in with the C-Reel card, and we use the spike relay to control the compressor. On the new PCM module, you have 8 solenoid outputs, so the same thing as you had before. Either 12 or 24 volt solenoids will work depending on your jumper configuration. You have an input now for a pressure sensor, and an output now for the compressor control, so you don't have to use that spike relay anymore to control your compressor. So it's all built into the pneumatics control module. The pneumatic control module also has CAN interface for communication and diagnostics, so you can get information back to your to the robo-reel for the solenoid, pressure switches, and compressor state. So the robo-reel. So the old C-Reel used the multi-card rack interface. So you had analog and digital signals that needed extra boards that you had to populate into your rack. You had Ethernet communication to the router, and it had that metal casing, so you had to make sure you had it properly isolated from your frame. The new robo-reel gives you 10 PWM inputs, 10 digital I/O inputs, 4 relay inputs, and 4 analog inputs. So that replaces your digital sidecars that we had in previous seasons. It also replaces the analog input board that we had last year too, that interfaced in with the analog card. We have multiple communication protocols now with the robo-reel, so you can do Ethernet, USB, CAN, SPI, I2C, serial. So they've opened that up quite a bit. The MXP, this section here is the MXP, or the MyReo expansion port. So that's used for custom circuits that can get you up to an additional 10 PWMs, 16 digital I/O, 4 analog I/O, or 4 analog inputs and 2 analog outputs. So now the new robo-reel has got that smaller form factor, and it's in a plastic case. Do you know where the new one is? Yeah. Okay. We'll look at it later. So it also has a built-in 3-axis accelerometer, and again, it's powered by a dedicated 12-volt source from the power distribution panel. Talk a little bit more about the MyReo expansion port. So again, this allows for custom circuit interface, giving you additional PWM, I/O, and communications. Some of the pins are used for dual purpose, so that's why I said it's up to. So if you kind of look at the diagram down at the bottom, you can either have digital I/O or a PWM signal mapped to the different pins. So you get one or the other, so you can't get the full complement. At the moment, there's multiple expansion boards that will snap right into that the MXP connector. So this is one example that's being sold on AndyMark right now from Rev Robotics. So basically, it just snaps on, and then you have your full breakout that'll sit on top of your robo-reel. So there's also, I put a link on the PowerPoint too for a link to a blog post about the MyReo expansion port. It goes into a lot more detail. Goes into discussion on what's going to be legal to be run off the MXP.
I do.
So they're still in development. Nothing's been formalized. We probably won't hear anything. So check out with what the MXP can be used for. So there's a more detailed comparison.
Yep.
From the previous C-Reo to the new control system.
It's the one with the Android and Apple.
Cost is also lower to get the complement of controls. Get more memory available on the new control system. The power requirements are slightly different, so you get a little, the robo-reel requires a little less power. Ethernet and CAN. Let's go through, gives you your digital I/O breakout, your analog I/O breakout. Your relay and pneumatic controls.
This is going to be interesting.
PWM. And then the additional power distribution changes.
Why do I not see? I know. Yeah, John, how does you use it? Yeah, that's what I'm looking for. What's that? Yes.
So this shows kind of the full overview of the new control system. So as you can see from your battery, go through your main breaker into your power distribution board. The power distribution board again has dedicated ports for the pneumatic control module and for your it just shows the pneumatic control module on here. It doesn't show the voltage. Oh, there it is. Voltage regulator module. So again, pneumatic control module will control your solenoids, compressor, and pressure switch. And then your voltage control module or voltage regulator module will control your Ethernet camera and then any of your other custom circuit stuff. Then your RoboRio, you can plug in USB cameras which haven't officially been approved yet. You can plug in Ethernet camera directly to your RoboRio, and then you also plug in your bridge or access point. Then from your power distribution board, send your power to your speed controllers, which are then connected to your individual motors.
Did you fuck those up? Or don't get her?
See if I can.
You. This might be some.
There you go. Sorry. I should have done this at the beginning. This works. Hold on, here we go. All right, sorry. Yeah. All right, hopefully everyone can still hear me out there. Let me double check I didn't mute myself.
We can hear you.
Okay. Sorry about that. All right. So again, your RoboRio, plugging your digital sensors, your RSL light, relays, your analog sensors, servos, and then the PWM signals to your motor controllers. So there's a link down here too to another blog post that discusses the new control system layout. So some of the other changes. The I/O and PWM ports are now numbered 0 through 9 rather than 1 through 10. So if you're trying to port some old code, old LabVIEW code into this year's LabVIEW, you're going to have to go through and re-reference or renumber your PWM and I/O ports. The old speed controllers are being discontinued after this year. So there's the new Victor SPs, which communicate over PWM, and the Talent SRX, which will be either CAN or PWM, are currently in the beta testing process. FIRST has not said yet if those will be available for this season or not. My gut feeling is that they will be, just because they're not making any more of the old style. So And also there's new camera options that are being tested. So you may be able to use USB-based cameras rather than Ethernet-based cameras. So CAN. So what is CAN? So CAN is a simplified and robust communication protocol used in many automotive systems and throughout industry. So it's used to send control and diagnostic information between your devices. The RoboRio connects to the PDP, the PCM, and Jaguars via CAN, and we'll be able to also communicate with the talents, the new talents. The terminating resistors are needed at each end of the network. So normally there's one built into the RoboRio, and then one that you put in the last item on your network. PDP has a built-in jumper that you can set to make it either use the terminating resistor or not use the terminating resistor. So that one makes sense to make that your end of line. And it just daisy chain wires through. So the web dash. So you can log on to the web dashboard via a web browser using either an Ethernet connection, a Wi-Fi connection, or a USB direct connection. So you'll log in, you open up a web browser and type in RoboRio, whatever your team number is, .local. So the number set is your team number without leading zeros. So for example, we'd be RoboRio 27.local. You can also use the IP address 172.22.11.2 when you're connected over USB. So the web dash gives you diagnostic information on the connected devices, allows you to monitor your CAN network, does some self-testing, fault resets, stuff all can happen through the web dash. You also use the web dash to upgrade your firmware and to manage your software. So the RoboRio software and then the CAN versions on each of the different devices. You need to use the web dash to set your CAN IDs and then to configure the RoboRio time. So LabVIEW software changes this year. So there'll be a new LabVIEW download that's available right now that basically gives you the LabVIEW 2014, the vision development module, the RoboRio driver, and the FRC 2015 simulation tools. But the specific FRC driver station and RoboRio utilities and the WPI library won't be available till kickoff. So you can download the majority of the LabVIEW stuff right now, and then when kickoff happens, you'll download the update suite, and that'll give you all of your WPI libraries and other LabVIEW functionality. The POV on your controllers, like if you're using the Xbox or the PlayStation or Logitech controllers, so your POV now uses degrees rather than buttons. I believe they used to be mapped to individual buttons. I know on FTC, I believe they're still mapped as individual buttons. This year, in the new version of LabVIEW, they're degrees. So now you have a 0 through 360 that you can use and get feedback from. There's some new component definition VIs, so your get joysticks. I believe some of your get blocks have changed. So you're not going to be able to directly dump 2014 code onto the RoboRio. You're going to need to go through and parse out some things. The best way that we've found so far to do this is to take a new project and try to bring your code from last year into the new project instead of trying to dump your new project and then figure out what needs to be fixed. So it's easier to start with the new baseline 2015 software and then bring in your customized stuff from last year. Okay. Let's get through that and we'll try that. So there's a new dashboard, new driver station. The RoboRio imaging tool is now built into the driver station. and we found that LabVIEW seems to be a little more reliable now during the downloads. So some of the lessons learned in our beta testing process is follow the instructions when you're upgrading your firmware and re-imaging the RoboRio. We had a situation where we updated them in the wrong direction, and we ended up having to revert back to old code and then revert back to old image tool and old firmware, and then re-go through the process again in the right order. So it's just time consuming, and you don't know why things aren't working because you're following the procedures you think works. But make sure you read and reread the instructions when you're going through and setting it up. We saw in a couple tests, we saw a periodic packet loss, where you'll see a spike in packet loss at a periodic rate. I think it was like 39 millisecond rate. So we posted that on the forum, and the feedback that we were getting was that it's the computer's Wi-Fi card is trying to pull for other networks. So it doesn't appear to affect communication, doesn't stop you from driving, but if you're looking at your log viewer, you'll see these spikes at a periodic rate that you say when you're losing packets. So if you're trying to search for a loose wire or something, it's probably not that, it's probably your wireless card. Some of the new features. So there's brownout protection now. So if the battery gets too low because the motor's overdrawing, the robot will be stopped momentarily to let it recover instead of doing a full RoboRio reboot. So the test that we did is we drove the robot into the wall, and then it would push into the wall, trip the brownout protection, and the RoboRio would basically stop and start, sound like a machine gun. So this is helpful because you don't have to wait now for the 30-second reboot if you lost the RoboRio.
You had to have 6 sims to trip it? Would it trip on 4?
We had 6. I guess we didn't try. We didn't try on 4. But it's still too, if you put in a low battery, if you run your battery down below, I believe it's 7 volts, approximately. Yeah, it'll go into that brownout protection mode to try to keep communication up. Voltage feedback from the power distribution board can be used in code now to diagnose and protect your motors from being damaged. So if you do see a certain motor drawing a certain amount of amperage or a large voltage draw, then you can use that as diagnostic and maybe shut down that device. So say maybe you've stalled out a motor while you're doing some operation, you don't want to damage the motor, you can put some feedback, either diagnostics to your driver station, or you can put it into code to be able to shut down those motors. The faults and errors are displayed to the web dash to make troubleshooting easier, and they'll persist across the power outage. You'll have a log of faults to be able to go back through and diagnose what may have went wrong. And those faults can also be programmed to display on the smart dashboard. So some of the tips and tricks. So there's multiple Windmuller connections. So that's a new type of connection that we haven't used in FRC before. So they're used on the CAN and some of the power, small gauge power. So you use the 16 gauge to 24 gauge wire depending on what the connection is. You want to make sure they're stripped 5/16 of an inch, and make sure that the wires are clean so you don't have a lot of whiskers hanging out. And then you can press in with a screwdriver on the white connectors. You push in your wire, and then let go, and they lock in. So they're good because they lock in. To get them out, you do the same thing, or the reverse. You put in your screwdriver, press the white button, pull out the wires. They have been pretty tight. They don't come loose that often. The only problem is that they're really close together, so you have to be careful with the whisker stuff so you don't short them out. The other thing is on the RoboRio, the PWM cables fit a little loosely, so they gave like a foam pad to put in there to tighten them up.
Oh, well. Yeah.
Yeah, sure, that'll work. Can you?
Yeah. So right now, we're connected to the robot. Full screen that.
Yep.
Yeah. So it shows just our IP addresses. We're not connected over actual Ethernet or USB, so I wouldn't show anything down here. But so this is our robot's IP address. This year when you're testing in your shop, it uses DHCP, so this IP will change. So if you do roborio-yourteamnumber.local, no matter what the IP is, it will always get to your roborio. You can run diagnostics on it now. You also use the web dash to update firmware. You can down here, or rename it. And then over here on the left side, you have your CAN interface, and that's where you can set your CAN IDs. So for our PCM, we have it set as ID 27, and the PDP is default to 0, and it should stay 0 because of just the way the VIs work in LabVIEW or other coding languages if you use those. And you can update your firmware for each CAN device as well, individually from the web dash. If you run a self-test on here, it shows you the status of each of your CAN devices. And so you can see if your solenoids are on, they're on or off. If your compressor is on or off, your pressure is full or not full. And then if you run, it'll also show if there's any faults on here as well. If you run a self-test on the PDP, it'll show if any current's being drawn from your power distribution panel, and what the battery voltage is, the temperature, and any voltage faults that it might have had, if it short-circuited or if the voltage dropped too low.
Does this just show the overall current being drawn by the PDP?
Little icon there. Yeah. It usually shows the individual current on each channel, and lately we have been seeing problems with that. They might release an update to fix that. You're supposed to have VIs to be able to view that live in your code, and we're still testing those VIs. They haven't gotten them to work completely yet.
Do they have functions that can do that in Java?
They should be able to, yeah. I think you have to add the power distribution panel as an object into your code, and then you can view the stats on that. This web dash here does not depend on what language you're using. It's for anyone.
How about temperature? You mentioned it. Temperature, that thing.
Yeah, down there it says temperature Celsius 20.95. So that's on the power distribution panel itself. Any other questions? Next on the web dash, we have this file explorer here. So I know our team used something called FileZilla last year to upload CSV files for our set points, and we haven't actually gotten that to work, but you can, once we figure out how to read from the files, we do know how to put the files on there. You have to log in, it's just the password is admin. Okay. Well, there's a file browser, and it shows all the files that are on the roborio itself, and you can add more files to it. And other than that, there shouldn't be anything else you need to do on the web dash. I think we got it. Very similar to the old one. You still have all of your diagnostic stuff here. Any changes? Do you have to put leading zeros on the team number before?
No, I believe those got stripped.
I mean, like last year.
I don't remember.
All right. Well, you don't need leading zeros any place on your team number. Whenever you're imaging your roborio or on your driver station, you don't need leading zeros for anything if your team number is smaller than 4 digits. This still shows all of your USB devices and any feedback from the buttons on them. I remember they did this last year as well, right? So nothing's changed there.
Mm-hmm.
And then this is a tab that is still in development. They haven't actually done anything with that yet. And yeah. So looking at our voltage, we have 12.4 right now. Driving in, we're at 10, 9, 8, 7, 6. And so you see it pulsating that once it realizes it's drawing too much amperage, it'll cut power. The power comes back. Now it has power, and so it sends power to the motors, and it's just a cycle. So, but you notice that our voltage dropped below the operating voltage for the RoboRio, but it didn't lose communication. So that's just to protect the RoboRio from having to reboot. So when you're in a match and you're in a pushing match and you start losing power and you see something like that happening, maybe that means pushing too hard, you should back off. Yeah. And obviously you wouldn't be pushing directly into a brick wall. The robots move a little bit, they have bumpers on them, but yeah, still you might encounter something similar.
Do you want to go ahead and do your...
From what you can hear, the video is going to be about, 30 seconds behind maybe?
Yeah.
But just, you can look, right now you're looking at the RoboRio. Just start moving it around. It's going to be behind. Move it. So now you're looking at the RoboRio. On the right side of the screen, you have your PWMs. And on the left side of the screen, you have digital input outputs. They're right along the sides. In the top right corner, there, you have your SPI communication. And towards the bottom, you can see a little black bar, and that's your MXP slot. We don't have anything plugged into that right now, but we have tested and verified that it works. And that just gives you some extra expansion because for some people, 10 PWMs isn't enough. I know a couple of years ago, we needed 2 digital sidecars. And so if that's your situation, you would end up using the MXP for that extra functionality. Now we're looking at the pneumatic control module. Now you're looking, voltage regulator module, and you have, on the top, you have 12 volt 2 amp, 12 volt 500 milliamp. On the bottom, you have 5 volt 2 amp, 5 volt 500 milliamp outputs. There are 2 of each, so that makes 8 total devices. They can be custom circuits, lights, the robot radio that can be powered off of this. And it shows status lights on it as well in case there's anything wrong. Now that's looking at the pneumatics control module. There's the blinking light on there for status right now. And that has, you can see CAN going in right there. CAN is how you control the pneumatics control module, and it feeds back the states of all the solenoids as well. And you have 8 total solenoid outputs. Their number is 0 through 7 though, instead of 1 through 8. That has changed. And you have an output for your compressor and an input for the pressure switch. And you don't have to program those. You just have to declare them in your code, and they will work. All right.
That's very good.
All right. So now you're looking at the power distribution panel. It's a little zoomed in. We got some lag here, so we can't actually see what we're pointing at. But just to talk a little bit about it, we said before that there are 4 less slots on the power distribution panel, and that is because there were 4 slots on the C-Rio. They all had to be powered. Now we don't have that anymore, and so they don't need the slots anymore. Now here you're looking at the status lights on the power distribution panel. They're blinking yellow. Those were blinking green before, but since we did that brownout test, the panel realized that it had low voltage, and so it started blinking the status lights. And these are the errors that we said before. They persist across power cycles. So after your robot is in a match, if you power it down, go back to the pit and turn your robot back on, those lights will still be blinking. And so your pit crew can tell that, hey, sometime during that match, we had a low voltage. And they can diagnose if that was a problem with your hardware or if you were just in a pushing match and your voltage dropped. And you will also see on the web dashboard, it will tell you what the error was, because there are different kinds of errors that can happen on the power distribution panel, and low voltage is only one of them. So when you open up the web dash, you'll be able to triple click on the self-test button, and that will reset all of those faults, so the lights will no longer blink yellow. All right, so you can go back to
So if anybody has a question, if you want to, you can use the raise hand button.
I got a question, have you tested anything in Java? Just
No one on our team really knows Java, so, no.
So my understanding is that they are a LabVIEW test
Yep.
team, and there are other teams that were C++ or Java.
Right.
At least Symbiotics might have been Java.
Symbiotic for Java.
Yeah, so Symbiotics will get that information up there.
All right, Jared?
Yeah. I was wondering, can you use an RC box with it
For control.
for controlling, like a control?
Like a Futaba or a Spectrum box to hook up to control the robot instead of like the Game Boy or, you know, joysticks or anything like that. Have you guys had any experience with that?
I don't think that's not legal to use in the game. If you had drivers on your computer that could find the inputs and send them to your computer, the driver station, you could do that, but you can't communicate over the 2.4 gigahertz that those controllers use because they want all communications to be sent through the driver station.
Yeah, I understand that. Yeah, but we want to use the box, and like you said, okay, so just get a driver for the PC that we can hook into, and then we can drive through there. And there was other teams that did that, and it all depends on the pilot. You know, it depends on what they're comfortable with. But you know, we just want to try out the RC box to see if that's going to work out best for us.
Yeah, we've never done that in the past, but I don't see why that wouldn't work.
Okay, thank you.
Yep.
Tim Peterson.
Yeah, will this webinar be available offline for other team members to view?
Yes. Yeah, so we're videotaping it here. We're trying to tape the webinar through WebEx. So we're going to try to get all that compiled hopefully next week. And we'll probably send out another email blast with where that's going to be located.
Okay, great, thanks.
Any other questions? Yeah. Not yet. So it's probably gonna be on the WPI screen scripts, whatever it's, screen steps. That's where at least the beta test stuff is located right now. So I'm assuming at kickoff they'll give everybody a login to get to that. Screen scripts?
Screen steps.
Steps. Script steps.
Yeah. Also, I know on LabVIEW they had this, and I'm pretty sure they have it in all the languages because it's very useful. They have example code that you can do. So if you want to know how to use certain sensors in the new environment in case it has changed, you can see what the example says. It has a visual on how you hook up everything. So if you ever have trouble on how you declare this in your code, how you read from it, they'll have examples on all different types of things you might encounter with your robot.
A couple of years ago, I attended a training session at National Institute on the old Rio.
Yeah.
You know if they're going to have any new ones for the new local Rio?
I am not sure yet. I'm assuming they probably would have something.
Check in the website.
But it probably is going to be after kickoff. I would assume at this point. Are there any other questions? Hartley, go ahead.
Can you hear me?
Yep.
All right. I'm looking at my RoboRio right now, and there's these 1 through 33 ports right above the National Instruments logo. What are those for?
That's the MXP.
That's the MXP slot. Yeah.
I don't know where
that in the presentation.
Yes, I can do that.
That is each of those ports is a couple of ground ports, but then most of the ports have dual functionality.
Try to get to it first. Okay, so yeah.
So some of them are PWMs, some of them are digital IOs, analog EMF relays, different communication protocols. You can, in your code, like if you want to turn on PWM 0, there's PWM 0 on the dedicated slots that you see on the right of the screen now, or there's also PWM 0 on the MXP board. And so you can actually have up to, I think it's 20 PWMs total if you utilize those ports. And what did FRC say about controlling motors?
So to control motors and things that cause motion through the MXP, let me get back to the MXP screen. They want you to use a first approved breakout board. So they've been testing those, and I'm assuming we'll get more information at kickoff on what the approved breakout boards are to put on there.
Okay.
Yeah, so far, we wanted to hook up some, there were digital sensors, and we had them in a single PWM, and we wanted 3 digital inputs right next to each other. And on the RoboRio, they're all spaced out. But we noticed, if you look in the bottom left, the pinout diagram, there's digital input outputs right next to each other there. So we just plugged a single PWM straight in, and that covered 3 input outputs. So we verified that it works. You don't need to do anything special in your code as long as you just declare that you're using the MXP instead of the dedicated ports.
All right. Thank you.
You're welcome. There was one question over chat that I saw about disabling brownout protection. I don't know that there's a way to disable the brownout protection. They have not told us any of that yet.
In our beta testing, we have told them recommendations of what we think should be changed, and that was one of our recommendations. Is it should make it more customizable, maybe change the voltage that it happens at, or change the time that it happens for, or even completely disable it. We have recommended that. And I know other teams have as well.
Is it hardware-based or will it not be able to be able to control it?
I'm not sure how that's set up. I would assume it's hardware-based, but I'm not positive.
And then, one thing you could do for that is in your software monitor the motor current. And if you're getting close to a brownout, you could selectively turn off the motors that it's okay to turn off and leave on the ones you go to.
Mm-hmm.
If you guys if you run a control with CAN bus, you guys does it have a PWM equivalent number, or how do you do that? Do you just play that?
So on the CAN bus, you assign an address to each individual device. So it's sort of like assigning an IP address to something on an Ethernet network.
You have to configure the actual
device.
controller if you get some kind of zip switches there or something?
When you plug in everything in your CAN bus, it all goes along one line, terminating resistors at either end. And when you open up the web dashboard, the RoboRio will recognize your CAN bus and it has this, in this order.
Oh.
And there, just to make sure, there's a button that says light LEDs, so it'll blink the LED that's on the speed controller, just so you make sure you're configuring the correct one. And then you type in what number you want it to be, and you shouldn't duplicate numbers, obviously, because that would cause problems in your code. But as long as you assign unique IDs to each thing in the CAN bus, then you can reference those in code.
And that one CAN bus you start with the RoboRio, go to the distribution manual, you go to the ones, and so you can terminate at that.
The RoboRio has a built-in resistor, and the power distribution panel has a built-in resistor, so usually those will be at your ends.
Oh, okay.
And then you have your PCM and speed controllers in the middle.
When you plug into the speed controller, are there 4 slots you connect to, or you got to do just a wire goes in and you got to do the connection on the way out?
The
RoboRio has 2.
Yeah, the RoboRio
that acts as your start.
On the PCM, there's 4.
There's 4.
There's the green, yellow, green, yellow. On I think CAN-enabled speed controllers are the old black Jaguars. You could plug in the phone jack connectors, and you have to make your own CAN cables there. Or the new Talons will be CAN-enabled, and those will have wires coming out of them already, and you just solder your own connectors up.
Okay.
And then, yeah, those will just go right into each other. And they'll have two sets of yellow and green wire coming out.
Yeah. If I'm understanding this right, like on the old system, we have a bunch of PWM wires going out to our controllers, and if one of them came loose, we lose that motor.
Mm-hmm.
The others are still going, but if they're all connected with CAN,
Yep.
and we lose the CAN wire,
You lose your network.
everything's dead.
Yeah.
So we probably want to keep our motor controllers all in the same area, so we have split wires in protected areas.
Mm-hmm.
Instead of putting the motor controllers like coming out in the motor. Is that right?
Yep.
Yes.
That's fine.
Yes. And we know other teams do use CAN, and they don't use it.
I don't know. But just to your point, I wonder if, again, it's the fact that you can actually walk one wire and you can have this a lot less wiring because you can, it has a lot less failure potential, there's less chance that we can drag back around, and you can just tie it on right along the path and stuff. So, again, I think it's a trade-off in terms of maybe there's some disadvantage, like you're talking about, one failure or those, but you also minimize the chance of failure because you can just, route right along the rails and just, the chance of you have a draft point.
We've never used CAN in the past because the only thing you could use that on was the black Jaguars, and you had to make your own cables. And you had to use a separate 2CAN module or something from across the road. And now that the Talons will be CAN enabled and they'll have the cables built right into them, we might consider using them this year because of what you brought up.
How many CAN channels does the Roborio have?
How many CAN channels? Just one channel, yeah.
Yep. So only one network.
Yeah. So you can have as many devices as you want on the channel.
Do you guys have a CAN network diagram? Is there any good resource?
The entire wiring layout we have.
Let me go back to the screen share. Sorry, I keep forgetting about that. So yes, the CAN wiring, it kind of shows it. So CAN is this orange dash line. So you have CAN from your power distribution board to your pneumatic control module, from your pneumatic control module to your RoboRio.
The Jaguars in the middle too.
Oh, sorry, and Jaguars in the middle. And then you can put anything in between, but it's laid out so that you'd start with your RoboRio and end with your PDP. Those would be your two terminating ends, and then everything else will be in between. Yep. So like on the web, what did we defined our?
The PDP should be 0. That is something that all of LabVIEW VIs use, or the Java methods. Those, well, probably all use 0 as their default, so you wouldn't want to change that. But then any other motor controller or the PCM, you can make that whatever ID you want. I think from 0 to 127.
Okay. Let me check back into the chat there. So yes, we'll try to make the URL links available once we're done. Cold boot times, code download times, and reboot times. About the same as with the cRio, I believe. I don't think they changed appreciably.
I think it does boot up faster. We have when we boot up and the computer automatically recognizes it, or actually, no, sorry. When we're hardwired in via USB, there's a USB-B connector on the RoboRio now. When we're hardwired in and we turn on the robot, the driver station recognizes that it's ready to drive within about 30 seconds. So it is pretty quick once the code's already deployed and everything.
The driver station is part of that FRC 2015 update, so we'll be able to get that at kickoff. CAN sensors to the CAN chain. I'm assuming you probably can. There's been nothing that says you can't, but we'll have to, again, look at the rules when they come out. And the C++ base code libraries, I don't believe those are available yet. I think all of that new stuff is going to be released at kickoff. I know there's still, as a beta test team, we're still getting updates to the NI software in LabVIEW. We just got one Wednesday. That's the pre-release version. So we're still doing a little bit of testing that'll probably go on through the holidays, and then they'll have everything ready to be released on January 3rd. Okay, so the approved speed controllers right now are the old, I don't want to say old, but the Victor, Talon, and Jaguars that we've used previously, and that are now not being manufactured anymore. But they have not opened it up to the two new ones that we're testing yet. FRC has not officially said those are available. Is it true FRC is swapping to Eclipse Ear for Java and C++? Since we did LabVIEW, I believe they are, from reading other things on the forum, on the beta test forum, but I guess I can't speak to it directly since we only did LabVIEW. I think that's all the chat questions. Let's see, any more hands up? All right, I don't see any more hands.
A question.
Yeah.
So I'm just curious, in general, for the controls, we have the joysticks and the Xbox controls and stuff. I assume anything you can plug into the computer you're allowed to use, or you can make them kind of customized. That's just curious.
That's, I guess, traditionally what it's been, yeah, is you could make a custom joystick. I know people have, made robot models with potentiometers where they've fed back the potentiometer feedback to basically direct drive an arm.
Okay.
I know we used to have a Cypress board on there. We had some pedals for shifting between gears that the drivers would use, and we haven't found any functionality for that on the new version.
Correct.
So I don't know if it's just the drivers or what.
I don't think it's a base function. You could write your own stuff for it, but it's not a base supported code anymore. The other thing too is if you're using Connect, it's not, you're not going to get the Connect stuff directly anymore.
You have to write your own.
You have to write your own.
Right.
Yeah, because like LabVIEW for us, we use LabVIEw. It recognizes joysticks to have like 20 buttons and 6 axes or 3 axes. And that's a standard joystick. So if there's anything different than that, then you might need to write your own libraries for it.
You had mentioned earlier that some of the buttons are moving to 0360.
Yes.
But if it's a push button and it's on or off, is it? How's that
That's
work?
the same as your point. Yep.
The POV hat here, it's now, it used to be different buttons for each of these 8 different positions. But now, because the controller actually you can only hit one at a time, now it's a single button, but it says 0, 45, 90, 75.
Oh, the whole
125,
180, yeah.
So it goes based on degrees.
So yeah, instead of giving you a Boolean feedback, it gives you a numerical feedback.
But that's just for that one little.
Just for that button. But yeah, we spent what 3 nights beta testing trying to figure out why this isn't working, and had to break it out and try to figure out what it was reading.
Okay.
Is there any other questions from the line?
Yeah.
Let me. If there's any other questions, I'll leave my my email address up. If you want to send me an email, we can try to answer those. Like I said, we'll try to get the video, the PowerPoint slide deck, and that all posted hopefully next week, so we can spread that around.
Yeah, they do use Eclipse.
Okay, so
looking at the screen steps now.
So yeah, so Eclipse is used for C++
And
Java.
Questions about compatibility with the old Rio. There's some stuff that came out on the FRC blog just yesterday, and they did say they were extending our LabVIEW license so we could use the old 4-slot Rios.
I guess.
But it said there wasn't support for the old H-slot PDA. We had some out, we don't want it to be used.
Mm-hmm.
You know what we can do about that?
I do not. I don't know if you can, yeah, 'cause I haven't read fully up on it about being able to use the new LabVIEW with the old controllers. I know they were talking about trying to make it still compatible. We haven't tested it yet. We right now have a new laptop dedicated for the new control system, and we have an old laptop dedicated for the old control system. So I guess that's the best answer I can give you right now is if you keep something that works with it working, so you can still use those.
Yeah, but license is required. They did say the LabVIEW license last year we extended to the sports license. I don't know why it doesn't also include the H-slot.
Yeah.
The beta updates that we've been getting, they're the updates for the RoboRio and updates for the sWebinar as well. So using the LabVIEW that we're using, the beta version of LabVIEW, we're still able, we haven't tried it yet, but we should be able to still upload code to the sWebinar as well.
Yeah.
So we don't need two separate versions of LabVIEW. But I don't know if that's just the 4-slot or the 4 and the 8-slot. I don't know.
But if you were to do that, you'd still have your numbering mismatch. You can't take the exact
Correct.
code
No.
and run it.
You cannot.
Slightly adjusted, so that at least the pulse would not with ID at minimum, if not
Mhm.
other stuff, right?
Yep, and I believe there's, some of the stuff has changed in terms of the loop timers and stuff. So that's why I said it's best to take the template code that they give you and import anything custom that you did in previous years into the new code format. I think I saw there was one more question. Couple more questions here. So any significant changes to the programming structure, like the hierarchy of LabVIEW code? I believe there's been some changes in there, but basically the structure is the same. We still have robot main, begin, teleop, on time, your periodic task. All those sub-programs are still there, but I believe, like I said, there was a change, I think, on the loop timers, or a loop timer was eliminated now for the RoboRio. So it's similar, but again, I would take the 2015 template code and dump that in. That's not a good message. Has anybody managed to crash the RoboRio? I have not heard of any crashes, but I guess that's just me. We haven't gotten feedback on anybody who's crashed it. Video tutorials or example code out there to learn C++ Java programming. Considering swap away from LabVIEW because of the deploy times. I guess I'm sure there are video tutorials and example code. Since we're still on LabVIEW, I haven't really looked. Have you guys looked at all at different?
I've looked. I saw there's a good one from a couple of years ago. One of the teams did about how to do Java inside the old NetBeans. We have now gone to Eclipse.
Mm-hmm.
So again, I would expect there's somebody out there put them up there. But I mean, there's already two issues. One is learning Java, and the second one is learning it for how to use it inside
Right.
FRC. So I'm not sure which one they're at.
Yeah, I guess I would assume the question was more towards the FRC specific stuff.
Yeah, there's always a screen chat thing or whatever.
Screen steps.
Yeah. I want to ask you, I was trying to understand in this department thing. We did LabVIEW last year. We had a LabVIEW expert from work. That was great. My experiences in Java. I was trying to move to Java over the summer just to play around with it. One of the things that came up just recently was when we hooked up the encoder and we wanted to look at that inside the driver station or the other thing. Is there a default, do you get access to it? And again, even if it's just a LabVIEW way, you'd look to see if you're getting the feedback. I mean, do you have to code it up, or do you get some out of the box that allows you to look and debug those things?
I believe you still have to code it up. You in LabVIEW, you still have to link it basically to your driver station. and I'm assuming it's the same way in Java to the smart dashboard. You probably have to pull it in. I don't know if there's anything that's pre-established.
That's what I was trying, I was looking around and had like the list of input outputs defined for PWMs and all this sort of stuff, but I didn't know. It just had them listed there and I couldn't figure out any useful on the driver station. And then on the other one, it looked like they might, I wasn't clear if there was someone once you define it that it provides you any kind of feedback inside the smart station.
I know last year on the driver station, there was a little window where you could paste your own information to the drivers. And we used that a lot, and they took that away.
Took that away?
And so now they want you to use the smart dashboard to communicate back to the drivers. We haven't gotten that to work yet, but we've never used it before, so we don't have experience in it. So we don't know if it's just a general smart dashboard thing or if it's something new this year that is different that we don't know how to do. I don't know.
Yeah, we just started kind of trying to focus on that on Wednesday.
Yeah.
So.
Yeah, we had lab expert and he talked to some team and he figured out how to get it to work. I have no idea how he got it to work. But it didn't work last year.
Yeah.
So we have not done any tests on running vision separately. I'm assuming the Arduino could plug in as a custom circuit.
Yeah, I mean, there's the SPI, there's UART, I don't know. There's a bunch of different communication protocols that the Arduino uses and that the RoboReel uses. So if you want to choose one and communicate between the two, you can do that. We haven't used Arduino for anything anything large on our robot. We just used it for lights, and we just communicated with PWMs, so it wasn't very complicated. But if you want to actually do some higher level communication, I think that would still work. I know teams have done it in the past. Should still work.
All right. Let's see if there's any. Yeah, I don't know if you could specify a core to put the vision on.
I don't know.
I think that's all managed internally, but I'm not sure. We didn't dive in that deep to it.
We never even thought about that.
See if there are any other hands that came up. All right, no more hands. Any other questions from the audience? Oh, there's more questions on the chat. So we've used basically the template code and added onto it in the past. I know of other teams that have basically stripped down the LabVIEW code. We were looking into doing that this year, but we haven't gotten that far yet. And in terms of that RS540 motor, we didn't receive any motors as part of the beta test stuff. So it's going to be probably something that will be determined in the kit of parts at kickoff, whether or not that motor will still be legal. Any other questions? One last through here. I'll put that. So again, if you have any other questions, feel free to email me, and we'll try to get those answered for you. Again, we're going to try to get the webinar and the slide deck posted somewhere soon. If there's nothing else, thank you all for participating. And, oops, there's one more question. Oh. Oh, you're welcome.
Oh, yeah.
Oh, there's one more. Yes, you can still use Victor motor controllers. You just won't be able to buy any new ones.
You can't use the Victor, or you can't buy the Victor 888, but you can still use them.
Yes, if you have legacy ones, you can still use them. So you can't mess with the RoboRio until after the kickoff. So if you purchase the RoboRio from AndyMark, I know those are supposed to be shipping earlier this week. So you can't use any, I guess, FRC specific stuff. I guess if you want to hook into it with LabVIEW, I'm not sure what exactly you could do with it. With just LabVIEW. You probably will have to wait until kickoff to be able to get the full complement. Yeah.
Thank you very much for taking
thank you.
Saturday morning.